Okay, part A says the position of the plane at time 20 is 152 miles. Use the fundamental theorem to create an equation which can be used to calculate the position at time 35. Really simple. You start with this. You say the fundamental theorem says if I integrate from time 20 to 35, the velocity, that's the same as calculating the displacement using the position formula. I really like how someone talked about this in 5 today. What they said was the fundamental theorem simply shows 2 different ways to calculate displacement. You do test or just drop this. What they said was, when you look at the fundamental theorem, you should notice that on the right-hand side, it's simply saying, if I need to calculate displacement, I can do that by using positions. Or I can calculate displacement by integrating velocity. So when you look at the fundamental theorem, don't think the theorem is saying this equation becomes this. The theorem is saying here are 2 ways to find displacement. That's why they're equal. So 2 different methods. Questions? Cool. So we can rearrange this equation. Another key thing. This is a really simple equation. Don't overcomplicate it. It's just 3 big items. It's really no more complicated than something like this. A equals B subtract C. And you simply rearrange the equation when necessary to suit whatever purpose you need. So one thing that will happen on the AP test is they'll ask you to find displacement. In that case, you don't need to rearrange this equation. You just need to figure out, should you be using this half or this half to calculate displacement based on what they're giving you. You need me to talk more about that. Part A is giving you another way you'll use this equation. You'll say, no, I don't need to calculate displacement. I need to find the position at time 35. So all I do is I add this to that half of the equation, giving me this equation. The position at time 35 will equal the position at time 20 plus the integral of the velocity. Question? Awesome. And then part B is showing the 3rd way that you typically use the fundamental theorem. So the fundamental theorem gets used typically in 3 different ways. 1, as is, to calculate displacement. 2, rearranged to find the position at the final time. Or I'm going to rearrange to find the position at the beginning time. But here the time period is 0 to 40. So I start out with the integral from 0 to 40 of the velocity. That has to equal s of 40 subtract s of 0. I want to find s of 0. So I'm going to add this to this side. Okay, I'm not finished, but does anyone have a question from this line to this line? Or want me to say it again or differently? Anything? Please.
How did like A relate to B?
Over here. Oh, this to this. My bad. So, really, here I was trying to solve for s of 35. So far, this is exactly the same as these. I haven't finished. Like here, I've so far solved for s of 40.
So you're just showing us how to solve A and then how to solve B.
Correct. Perfect. 2 points. Anyone else? But the goal here is to get S of 0 alone. So look, the integral is, just think of it as one entity, like one big thing. And so I can take and subtract this from both sides. So I get this formula. And that's what they're asking for in part B, is a formula for calculating the position at time 0. Please.
Do you not want the S, but, well, because like looking at the first thing, I probably, just to get it by itself, I would have just like subtracted the S of 40 on the other side, but then that would leave the S of 0 negative. So is that why you did it twice? So negative?
Nothing wrong with what you just said. Think of it this way. If I start here, and like you said, I subtract the S of 40 over, I'm going to get this. I'll have, let's see, negative S of 40 plus the integral 0 to 40 of B, and all of that will equal negative S of 0. You comfortable with that?
Yeah.
And then you're right, because this is negative, I'm going to multiply both sides by negative 1. Well, if I multiply all of this, all of this by negative 1, the negative 1 has to distribute. So this will switch back to positive. This will change to negative. And I end up with the same thing. So either way, 2 points for Cassidy. Anyone else? Please, Laura.
Do we need to show how we got there, or can we just give the equation that, like, does that make sense?
2 points. So this worksheet isn't, some of the questions on this worksheet really are straight from AP tests. But some of them are designed to kind of help you learn, not necessarily test you. So I've never seen them, well, no, back up. No, there have been AP questions where they simply say, write the equation. You don't have to show any work. You can just write it. Yeah, they don't expect to see it. I was just showing. So. 2 points. Anyone else? Cool. So moving on. Okay, we have never demonstrated what a midpoint Riemann sum is, but, so look at me. Okay, like many things in this class, if we can think of a way to think of the concept in a, what I would call common sense way, then it becomes immensely easier to memorize the concept than it is if it's like, here's the rule, good luck. Fair? So think of it this way, and I think your common sense will take over and you won't have any problems ever with midpoint Riemann sum. When we're doing a, see, we're going from 5 to 35. So here we go, 5 to 35. And it says 3 subintervals of equal length. So that means I'm going to go to 15 and then to 25. So there we go, perfect. Okay, here's my first subinterval. If I am doing a left Riemann sum, I look at the first subinterval and I pick the time that is most left. If I'm doing a right Riemann sum, I go to the first subinterval and I pick the time that is most right. So raise your hand if you can guess, following that pattern. If I'm doing a midpoint Riemann sum, think of the word midpoint, what time within the subinterval would you expect to be choosing when you're doing a midpoint Riemann sum? Nathan? 10, because 10 is the middle time. How many know it? 0.2 for Nathan. Question? Please, Carter.
What if you're looking at 16 and how to go between?
Gotcha. 2 for Carter. Listen up. So Carter's logic is perfect. You do need to pick the middle time. But because they're testing you, they don't want to cause Like they want you to be challenged, but they don't want to cause like ambiguous confusion. So they won't ever give a question where the middle time is not obvious.
So the reason that we're doing like the graph compared to the chart is just to visualize it that way.
Perfect, yes. You can visualize on the chart as well. You'd say I got to go from 5 to 15, 15 to 25, 25 to 35. So either way, 2 for K. That's it. What happened again? He got sick. So he is being attended to. So he just got sick to his stomach. Might be the pain medication or something that can cause that. So. Okay. One caution. I think I showed this last time, but I saw someone, I've actually seen 2 people already make the same mistake I warned them about, which happens to all of us. Do not look at the table and divide the table like this. I think I showed you. Yeah, straight lines. Like I've already had a couple of people come to my desk and they're like, I can't get 3 subintervals that are equal. They're drawing things like that. Don't draw that way. Draw the way I showed you a minute ago, like this, like that. Then you won't make the error. Questions? Cool. Do C, D, and E go? Hold on a second.
It's fine, so you would subtract the negative, and then you...
I had these two. So I had it 20 minus 35.
Yeah, no, 35 minus 20. So even if we just like, so let's just do this. So let's just say you're going to bring all the 45 years and so we bring it over, it becomes a negative. You're going to subtract that. So then you have to get 35 by itself.
Like I know how to set that all up. I'm just confused of why this is 35 minus 20. Like not 20 minus 35.
Because it's the end minus the beginning. So you're at 20 years ago. You want to take the 35.
So it gets 250 miles.
Yeah, how did I ask? Yikes. Stormy girl.
What's the answer today?
164 miles.
Okay, check your work. Please, Mike. So it says here on E, use the midpoint Riemann sum, approximation above. So I'm supposed to use this right here to estimate the position of the plane at time equal 35. So it's kind of a guided problem. So in part D, we wrote an equation for finding S of 35. That equation says I have to know the position of the plane at 5, which is right here. And then I have to add that to my approximation of the integral. 20. Please.
Does it matter on like the 203 if you do do like an approximation, like you have to write, like we'll for the equal.
Oh,
it's like
gotcha.
Does it matter if you put that or no?
They're not real picky on that one. So I have developed the same bad habit. Like I kind of just go in and out of equal and approximate. I know that when I'm calculating the integral, it's definitely approximate, for sure. So S of 35 is actually perfectly equal to this. So that really is an equal sign. You don't want to put approximate there. So S of 35 is equal to 39 plus something.
Yeah.
Yeah, it just gets kind of fishy, so they
So it
don't
doesn't quite
stress
matter.
about it. Yeah. 2 points. Any other question? Okay, who has this written on their page? Sure. Yeah. 2 points. They want to talk more? Okay.